Today, I wanted to talk about function typing, meaning assigning types to the different parts of a function call in order to tell TypeScript what we're expecting where. Imagine we have a function called doesResource_exist. We'll need an ID and a resource type for it to work. And whatever we return is most likely going to be a true or false, depending if the resource does exist or not. If we want it to be very explicit about the types that we're expecting, we can declare them here. So for the first argument, or the ID argument, we'll always expect a number. And for the resource type, we'll always expect a string. If we try to call this function now, VS Code will automatically read TypeScript and let us know that the first argument needs to be a number, and the second argument needs to be a string. Great. No errors found. Hovering over this, again, we get a quick, clear answer as to what TypeScript needs for this function to work. We also want to make sure that the caller always knows that the response or the return will always be a Boolean. True, false, no matter how difficult or complicated the logic is, it's always going to be a Boolean. Declaring the type here, even though we're returning true or false, will also let us know within the function if we're returning something that is not a Boolean. For example, if we try to return a string that says yes, TypeScript lets us know that it's not assignable to type Boolean. So this is not just to let the caller know what we're expecting, it's to let us know within the function what we're expecting to return. We assign that function call to a variable. TypeScript and VS Code will immediately know that that variable is going to be a Boolean. So if we run if exists, we can use it this way, no problem. Probably not the best example. Let's talk about how to make functions generic. Making something generic means that you're able to, just like in a function, pass in a variable type, and you can use that variable type in various different places. Let's see what that looks like. Imagine we have a function called getResource. If you watch my video on generics, this will seem familiar. This will seem identical. We need an ID and resource type, and we're going to return some kind of resource, whether that's a user or a post or something entirely different. Let's make sure that we always get a number for an ID and a string for a resource type. And what we're going to be returning, well, that's a good question. Normally, I just write any, but we have the power of generics, and so we can actually let the caller specify what kind of return type they expect. Right now, if we call getResource, neither VS Code or TypeScript know what we're going to get back, and that's a problem. Because then we don't know what kind of operations we can do on the variable here. So what we can do is use generics. The syntax for generics is these two angle brackets, and passing in a letter is, well, at least that's been the convention that I've seen. Whatever else you want in here, this is called a type variable, and the type variable can be used in a bunch of different places. Anywhere you would write a regular type, like the number here, string, or to return, you can use the variable type, or the type variable instead. So in our case, we're actually going to let the user specify the return type. Now here's a problem. It lets us know that type empty braces is not assignable to type u. There are a few things that we can do about it, but the best one that I've seen is just letting TypeScript know that whatever this result is, it's always going to be type u, which in our case will be. Great. Now there's something odd. GetResource here just assumes that it's an empty object that we're returning just because of this. But in real world, we actually would not know what we're getting back. TypeScript is inferring that the u that we're trying to pass in is this empty object. In our case, we're actually wanting a user. User is an ID and a name. Because we're forcing this as you over here, TypeScript is not going to throw an error just because we're returning an empty object. This kind of sucks, but for the purposes of the tutorial, this is kind of the only way to show how this works. When you hover over the getResource signature, it substitutes that user for the U that we have up here. Right here. And TypeScript already knows, and VS Code does as well, that the user variable here is going to be of type of that interface user. That way, we can call on things that we really need. And that's it for function typing. Check out my next video, or there should be another video, and I'll post it in the notes, that is going to go over how to use function interfaces.